Hello students, in this video we'll discuss how to reduce the order of a differential equation once a particular solution is known. So we will suppose that we have found a solution, y1, to a second order equation. Linear equation. We can reduce the order of the second order equation to a first order equation by making the following substitution. Make the substitution y equals a new variable v times y1, which is the function you found. So our substitution will be v times the solution you found. Let's see how this example works out. Let's solve 2x squared y double prime minus x y prime plus y equals 0. We notice that this is a second order linear differential equation. Which means that if we can find one solution, we can reduce the order. The question becomes is how we can find one solution without any information. Oftentimes, by looking at the differential equation, we can postulate or guess an elementary solution. So we can notice that in this particular equation, if y equals x, then y prime equals 1, and y double prime equals 0. So if we plug x into the differential equation, we have 2x squared times 0, the second derivative, minus x times y prime, which is 1, plus y, which is equal to x. That's 0, and the x and the negative x will cancel, and we get 0. So we can conclude that y equals x is a solution. Now we'll do our reduction of order trick. We let y be v times the function we found, which should be a solution. So we have v, and then y1 is our x. If y is vx, this tells me that y prime is v plus x v prime by the product rule, and tells me that y double prime is v prime plus x v double prime plus v prime, or x v double prime plus twice v prime. Now we plug in this expression into the original equation. So our original equation becomes 2x squared, and y double prime is now x v double prime plus twice v prime. So I have x v double prime plus twice v prime minus x times y prime, and y prime is v plus x v prime. And finally, plus y, and y is v times x. Set it equal to 0. Now, we notice that I have a vx term over here and a negative vx term over here. So those two terms will cancel out. And the equation, therefore, becomes 2x cubed v double prime plus 4x squared v prime minus x squared v prime equals 0. Simplifying, I can turn this entire expression into 3x squared v prime, and we arrive at our equation for v, which is twice x cubed v double prime plus 3 x squared v prime equals 0. Canceling out the factor of x squared, this is equivalent to 2x v double prime plus 3v prime equals 0. And writing it in a more suggestive form as v double prime plus 3 over 2x 1 over x v prime equals 0, we see that this equation is a linear equation in v prime. So this equation is linear in v prime. The integrating factor we will use is e to the integral of this. E to the integral of 3/2 1 over x dx, which we can check will be x to the 3/2 power. So multiplying the equation by x to the 3/2 power, I see that our equation becomes d over dx, x to the 3/2 power, v prime equals 0. Integrating both sides tells me that x to the 3/2 power v prime is a constant c1, or equivalently, that v prime is a constant c1, x to the negative 3/2 power. Integrating this, I see that v is equal to a constant c1 that's modified with the power, x to the negative 1/2 plus another constant c2. So I've now found v, which depends on two constants c1 and c2. So my solution y must be v times x. So the solution to our problem y is v c1 x to the negative 1/2 plus c2 times x. Simplifying this, we see that y is c1 x to the 1/2 power plus c2x, and we have solved our equation by finding one solution. Thank you very much.